Hello everyone. Today we are going to share about our Mathematics 1 assignment. Before we start, let's us introduce ourselves.
Hello, I'm Ko Yishin.
Hi, I'm Joshua.
Hi, I'm Junyan.
Hi, I'm Shihong.
Hello, I'm Hari.
Hi, I'm Mario.
Hi, I'm Ling.
Hello, I'm Christabelle.
Hello, I'm Alan.
Hello, I'm Shazwan.
Due to the climate change, the occurrence of floods increased throughout the country. Some of them survive and some do not. We are assigned to design a product that is useful for people to survive the flood.
So our final product is survival capsules. We have drew some perspective view by using our Desmos calculator, including front view, side view, back view, and so interior view. So let us look at the front views. We have used a lot of different equations and functions, including trigonometric functions, polynomial and rational functions, linear equation and also quadratic equation to make our product look more reality. For example, our body have used the spheric equation, which is ax squared plus by squared is equal to 3. While inequality are mainly used for coloring by setting up the range to choose the periods or the parts to be colored. And there are some special parts that we conduct to make our products look more 3D, which is our handles and our shadows. For the handle parts, we have used 4 different lines and different color to make it look layers, and for the shadow parts, by controlling the variable which is our cosine degree, we control the degrees to make an oval and also a dark shadow. And also the interior view. We have safety seats, which have a belt that is adjustable, and of course we have the basement, which is for the storage purpose. Inside is including 1 first aid kit and also 2 bottles of waters for emergencies. So now showing is, well, we are illustrating our product in use while during the flood or all the disaster. For the flood and all the wave, we have conduct a lot of trigonometry functions, especially sine rule. By controlling the degree and the x and also the y intercepts, we can control the wavelength and also the amplitude to make it look like a reality wave, and also it's in a flood situations.
The concept behind our survival capsule is to protect occupants' life in a life-threatening situation, especially during natural disaster, extreme weather events, or massive floods. Some concepts behind our capsule, including the outer layer, which is made out of aircraft-grade aluminum. The glass paint used for coating is to reflect light, so it can be easily spotted by rescuers. We also use polyester fabric coated with PVC or polyurethane because it's durable and water resistant, and the windows are made out of Lexan because it is strong and is resistant to high impact. For medium layer, we use polyethylene foam because it is lightweight, buoyant, and water resistant. Round steel tubing frames are used all along the capsule because of its strength. Solvethane can absorb up to 94.7% of shock energy, and Freeman marine deck hatch door made out of aluminum is used to prevent entry of water. The inner layer is mainly consists of neoprene rubber because it is highly resistant to water, weather, and any kind of abrasion. Polyester and nylon is used for seating to provide comfort for the occupant, and silicone sealant is used to seal the joints and seams of the survival capsule to prevent water from seeping in.
Next, there are 2 physics concepts that is involved in the making of our survival capsule, which is first, buoyancy, and second, shock absorption. For buoyancy, we're going to explain about the importance of buoyancy in a survival capsule, concept of buoyancy, and also how to calculate buoyancy. The importance of buoyancy. Buoyancy is the tendency and ability to be able to float on water. The buoyant force enables survival capsule to stay afloat while maintaining its stability in water.
To understand how buoyancy works, consider a submerged object such as the submerged survival capsule. The weight of the capsule exerts a downward force which is equal to the force of gravity acting on the capsule while the water exerts an upward force. The buoyancy force acting in the opposite direction of weight must be greater in order to keep it afloat. Otherwise, if the weight is far greater than the water's buoyancy force, it will sink. To increase the buoyancy of a survival capsule, designers can adjust its shape and size as well as the materials used to construct it. A more buoyant capsule may require a shape that can maximize the amount of water it displaces in order to experience an even greater buoyant force. Thus, the more water the survival capsule is able to displace, the greater the buoyancy force. Introducing Archimedes' principle, buoyancy can be calculated based on this theory. The concept states the buoyant force acting on the object is equal to the weight of the fluid displaced by the object. This principle can be expressed using the equation, where Fb is the buoyant force, ρ is the density of the fluid, g is acceleration due to gravity, and v is the volume of fluid displaced by the object. The next physics concept we will investigate is shock absorption and its importance as well as the concept and its calculation.
Shock absorption is an important feature in our survival capsule, as our survival capsule are designed to protect occupants from high-speed collision. One of the critical functions of this survival capsule is to absorb and dissipate energy of this impact to prevent injury to the occupant. The concept of shock absorption. Shock absorbing materials are equipped to withstand high force and provide protection to avoid occupants from being crushed by debris. The overall concept of shock absorption is critical in ensuring the survival and safety in passenger by reducing forces of impact and allowing capsule to maintain its solid sphere shape without causing any internal or external damage. When calculating the shock absorption, there are a few factors that we need to consider. First of all is the features of shock absorbing material, magnitude of impact, and also velocity of object being impacted. The formula that can be used is the kinetic energy, which is 1/2 multiplied with the mass and the velocity with the power of square. The shock absorption can be calculated by the difference between the initial kinetic energy and the final kinetic energy divided with the initial kinetic energy. The value of shock absorption is determined when the higher absorption, the more effective the material is at the reducing the force.
So for the commercial one, we are going to set up our own website and do promotions and advertisements on social media such as Facebook, Instagram, TikTok, and etc. On the sales part, on our website there are two packages to choose from, basic or premium. For the basic package, there is basic furniture inside, MRE which is meal ready to go, water bottles and first aid kit. For the premium package, everything in the basic package plus a GPS, 2 life jackets and a torch. You are also able to buy add-ons such as walkie-talkie, backpacks, gloves, whistles, local maps, canned foods, extra batteries or oxygen tanks. You are also able to choose your own preference color for your survival capsule. For commercial 2, we are going to talk about the cost of the materials we will be using in the outer, medium layer and the inner layer.
So, the outer layer of the survival capsule are made up of 4 parts. The first component is aircraft grade aluminium. It costs 27 ringgit per kilogram. The second component is electron window, which costs 28 ringgit per meter square. While the third component is glass pane. It costs 10 ringgit per liter.
Okay, next for the last one of the outer layer is the polyester fabric coated with PVC or polyethylene, which is cost 15 ringgit per meter square. For the medium layer, there is polyethylene foam which costs 53 ringgit per meter square. The second one is round steel tube beam frame, which is 23 ringgit per meter square.
For the Freeman Marine Deck Hatch Door, it is made of aluminium and it is estimated to be around 400 ringgit per door. And also for the medium layer is Sorbotane, which is estimated to be around 45 ringgit per meter square. And then the inner layer is neoprene, which is around 40 ringgit per meter square.
Next, the polyester and nylon used in our inner layer cost us 9 ringgit per meter square, while the silicone sealant will be 11 ringgit per kg. That is all from us.
Thank you!